lesson is about absolute value. When we look at the absolute value of negative 3, we have to understand that that is the distance from negative 3 to 0 on a number line. So here's the point negative 3, and it is 1, 2, 3 units from 0. So that's why the absolute value of negative 3 is positive 3, because distance is always positive. So let's look at these statements. The first one says the absolute value is equal to 3. This means that the point is exactly 3 units from 0. The second statement is read that the absolute value is less than 3. And this means that the absolute value is less than 3 units from 0. The final one says that the absolute value is greater than 3, which means that the point is more than 3 units from 0. So let's look at some graphs. To graph the statement absolute value of x is equal to 4, we're looking for all points that have a distance of 4 units from the origin. So all numbers whose distance is whose distance from 0 is 4 units. So I can count 1, 2, 3, 4 units away and be right here. But I could also count 1, 2, 3, 4 units and be right here. So the solution to that equation would be the points negative 4 and positive 4. Now if I look at the absolute value of x being less than 3, I'm going to look at those points where the absolute value is equal to 3 and think about distance. Absolute value, read that distance. So this says that the distance is less than 3 units. All of these points are less than 3 units from 0, and all of these points are less than 3 units from 0. So this is what our graph would look like to show all numbers whose distance from 0 is less than 3 units. In order to write that, we can write it one of two ways. We can either say that x has to be less than 3, and at the same time, x has to be more than negative 3. We can also combine that into a single statement. Since what we're graphing is the area between negative 3 and 3, we can simply say that x is between negative 3 and 3. The inequality would look like this in that case. The next one says that the absolute value of x is greater than or equal to 2 units. So again, let's look at 2 units away from 0. Distance from 0, I want to be greater than, and that line underneath it means or equal to 2 units. So right now I'm just showing where the 2 units are, but since it can equal to, we're going to fill those in. And I want my distance to be more than 2 units from 0, so I need to go away from 0 off of both of those points. I cannot write that in a single combined inequality because I have 2 separate pieces. So the way we write that solution is this half is read x is less than negative 2, or x is greater than or equal to, or equal to on both of those, 2. Now I want you to stop the video and go do the first 4 practice problems. Once you have those 4 completed, turn the video back on and check them. Okay, let's check your answers. The first one says that the distance from 0 has to be strictly less than 1 unit. Here's where I'm finding 1 unit. My distance has to be less than that, so my graph should look like this. We can write our answer as a combined inequality with your x going from negative 1 to 1. The next one says that the distance has to be greater than or equal to 4 units. These are the 2 locations where the distance is equal to 4 units. That would be 4. Since it can equal 4, I'm going to fill in the circles. And my distance has to be more than that, so I'm going to be going away. We would write x is less than negative 4, or x is greater than 4. The next one says that the distance has to be less than or equal to 3 units. So we're going to locate where it's equal to 3 units. Since it can be equal to, we are going to fill those in. Distance has to stay less than that, so we're going to stay closer to 0. Our solution would look like this. And the final one, the distance is exactly equal to 2 units, so I'm looking at the two places where it's 2. Since it can be equal to, we're going to fill in those dots, and that would just be the set including the points -2 and 2. Now let's look at number 5 together. This says that the absolute value has to be equal to -4. Distance is always positive. Therefore, there can be no points with a distance of -4. To show this on a graph, we would simply leave our graph blank. Our solution, we can use the symbol for no solution. Now stop the video and go try the next 3 examples on your own. When you finish those 3, start the video again to check your answers. Number 6 says that the distance has to be strictly more than 5 units. So we locate the two places where it's equal to 5. It cannot be equal to, so we don't fill in our circles, but then we're going to show distances more than 5 units away. Our solution would be x is less than -5 or x is greater than 5. The next one has a bit of a twist. Remember that absolute value is positive, so our statement actually is saying that we have a positive number that is bigger than -3. The question you ask yourself is, when is a positive number larger than -3? The answer is always. To show this on our graph, it will look like this, and we can use the symbol for all real numbers, or we can write out all real numbers. Using that same logic, let's think through this one. Now what we are looking at is a positive number less than -2. When is a positive number less than a negative number? The answer would be never, so we have no solution, and we leave our graph blank. Since absolute value refers to the distance from 0, funny things sometimes happen when the number on the other side is 0. You need to think through these cases very carefully. For example A, we have strictly greater than, which means x cannot take the value of 0. So we're going to put an open circle at 0. But my distance can be anything more than that. So I would be going in the positive direction and in the negative direction, which leaves almost all of my graph covered. The only number that is not okay is 0, so we can simply write x is not equal to 0. The next example says that our distance has to be less than 0, which implies a negative number. And again, since we have strictly less than instead of less than or equal to, 0 would not be included, which means there are no points that would have a distance of strictly less than 0, so we would have no solution. The distance from 0 being equal to 0 happens only at the point 0. And since we have equals to, we do fill in the dots. Our solution here would be the set including the point 0. Example D looks a lot like example B, except we have less than or equal to instead of strictly less than, which allows us the case of x being equal to 0. Because of that, we do have one single point where that will work, and so 0 is again a solution here. Again, E is similar to example A, except this time we include the option of being equal to 0. So that one hole that we had in graph A is now filled in, so every point would be a solution. Again here, we have all real numbers. So what about this one? We actually have two different pieces that we need to deal with. When we think about the absolute value of being equal to 1, that's going to give us the points -1 or +1. This point is 1 unit from 0, so is this point. When we look at absolute value of x being equal to 4, that gives us the points -4 or +4. We can be here or we can be here. So to write our solution set for this, we would have to include all 4 points. It would be the points -4, -1, 1, and 4. If you notice, all of the problems we've been looking at so far have had absolute value of x isolated all by itself. That's not normally going to be the case. So when you have to solve an equation or an inequality involving absolute value, the first thing you have to do is isolate the absolute value. You need to get that absolute value all by itself. And then you can write the solution set in the way we've been doing all along. So let's look at this first example. We have the absolute value of x -3 equal to -1. Thinking through solving, the first thing we would do is add 3 to each side. So when we do that, we're going to get the absolute value of x equal to +2. Continuing to solve now, that's going to give us points at -2 and +2. That would be our solution set. So let's look at the absolute value of x plus 2 being less than or equal to 6. Again, think about what we would do first. We're going to need to subtract that 2 from both sides. Once we do that, we're going to have the absolute value of x less than or equal to 4. And we already know how to graph that. 4 would be included, so would -4. I need my distance to be less than 4, so it would be all the points in between, giving me an answer that's going to look like this. X is between -4 and 4. And our final example. Go ahead and solve this one on your own and see if you can come up with a graph, and then resume the video and check your work. Once we add 1 to each side, we're going to come up with the equation that the absolute value of x is greater than 3. And that's going to give us points that are strictly greater than 3 or less than -3. Those points are not included because we do not have the or equal to on the inequality. I need my distance to be further away from 0, so it's going to look like this. So x is less than -3 or x is greater than 3. That's the end of the notes. Tomorrow in class, we will be doing some more complex problems with things other than just x inside the absolute value, but it will help to have a sense of how we solve absolute value problems.